My name is Usama Mansour, and I'm a solution architect in Databricks. In the next few minutes, I want to introduce you to Databricks Lakehouse, and I will show you how security operation teams are using Databricks Lakehouse to reduce their cost and increase their security operations through advanced analytics and improving their risk posture in multi-cloud environment. So for today's agenda, first we will be talking about what is Data Lakehouse, and then we will cover Databricks in cybersecurity, what are the applications of Databricks in cybersecurity world, and then I will show you how Databricks with Splunk integration would work, and then I will walk you through a demo, and then as I said, we'll have some Q&A time. So what's Databricks? Databricks is data and AI company, and we are inventors and pioneers of Data Lakehouse. And Gartner has recognized us as a leader in both database management systems and data science and machine learning platforms. We are also the original creators of lots of OSS data projects like Apache Spark, Delta Lake, MLflow, amongst others. And we are working with more than 6,000 customers worldwide. You can see from screen, you can recognize some of these brands as customers of Databricks. So data analytics and AI have been the center of innovation. Banks and others led the way and showed everyone the opportunity. They put data and AI use in really strategic ways that change the landscape. The left-hand side of this graph is looking backward. This has been the domain of data warehouse for decades. As you know, that data warehouses are here for almost like more than 40 years. But in fact, the innovators are over on the right-hand side today. They are using data to predict the future, looking at how you will behave or how the environment is behaving and are reacting in real time. Instead of being reactive, you are now becoming a proactive. But it's not just them. Some enterprises have been having success too. The challenge is that most companies implement two different platforms to answer their questions. Data warehouse for BI use cases and data lakes for AI and machine learning. These two platforms are incompatible with each other, but you generally need data from both systems to deliver really game-changing outcomes, which makes success with AI extremely difficult. Let's look at the reasons why this happens. Today, most of data is landing in the data lake, and lots of it is either semi-structured or unstructured. But this data is where a lot of value from AI and machine learning is sitting. Then subset of data are being copied to the data warehouse into structured table, and then back again in some cases. You have to secure and govern the data in both platforms. Data warehouse offer really fine-grained access controls, while data lakes are more coarse-grained at file access level. Then you stand up different stacks of tools in these two platforms to do either BI or AI. This operating model creates three problems. First, you have duplicated data in two different systems. Changes you make in one system are unlikely to find their way to the other. So you are going to have data drift almost immediately, not to mention paying to store the same data multiple times. Then, because governance is happening at two different levels across these two platforms, you are not really able to control things consistently. You have to apply lots of security controls in different ways. And finally, the tool stack on top of these platforms are fundamentally different, which make it pretty difficult to get any kind of collaboration going between teams that support them. So you've got data engineers are supporting one platform, you've got data analysts working on another platform, you've got data scientists working in a complete platform, and it is very difficult for all these teams to be working together. This is at the heart of why AI efforts fail. There is a tremendous amount of complexity and rework being introduced into the system. Time and resources are being wasted trying to get the right data to the right people. And everything is happening too slowly to get in front of competitors. This ideal data and AI platform would operate differently. Rather than copying and transforming data in multiple systems, you would have one platform that can accommodate all data types. Ideally, the platform would be open too, so that you are not locked into a walled gardens. You would also have one security and governance model. It wouldn't only handle all data types, but it would also be cloud agnostic to govern data warehouses wherever it's stored. Last, it would support all major data and AI workloads so that your teams can easily collaborate and get access to all the data they need to innovate. This architecture exists today, and it's called a lakehouse. It's the approach we've invented at Databricks to help customers deliver on their data and AI aspirations. So with Databricks Lakehouse platform, you are able to have all your data, structured, semi-structured, and unstructured in one place. We then bring reliability and extremely fast query performance to that data without leaving the lake with an open technology called Delta Lake, so that you can use it for data warehousing workloads. Next, Unity Catalog provides governance for all of the data with one consistent model. The advantage of this are, first, you are dramatically simplified your data architecture for all your workloads, data warehousing, data science and machine learning, as well as data engineering and data streaming. Second, the entire platform is built on open platform and open standards. This means you have a lot of freedom on how you evolve your data strategy without walled gardens restricting present and future choices. Not to mention the vast community of talents that resides in open source community. Finally, you get one consistent experience across all clouds. You don't need to invest in reinventing the wheel for every cloud platform you are using to support your data and AI efforts. But of course, one company can't do everything. So because Databricks is open, you are able to take advantage of a huge ecosystem of hundreds of tools and open source projects, and everything from ingestion and pipelines to the growing library of machine learning tools in the market. Using platform, many enterprises are unlocking needle-moving opportunities in their businesses. In addition to our technology, Databricks brings a strong collaborative partnership to every engagement. Our expert professional services and partner work alongside you to help enable your users and IT teams to adopt the platform. Our experience in partnering with thousands of customers has allowed us to develop proven industry-based solutions, accelerators, that brings together the data, people, processes, and technology to get up and running fast. So how does this relate to cybersecurity? Now you understand the lakehouse. Now let's take a look at cybersecurity problem. Cybersecurity has always been a big data problem. In recent study, over 200 CISOs said they have been breached at least once. 67% said they were breached at least 3 times. And 85% of them have said there is an increase in cybersecurity budget because cybersecurity breaches are very expensive. An average breach could cost around $4 million. And the reason for that in cybersecurity is an operation that requires expanding footprint to be monitored and secured. Organizations are cloud and multi-cloud, and they have hundreds of tools are required for compliance and monitor. Data in these tools are proprietary and locked in storage format, and maybe locked in and don't make it easy to get integration with other tools. And as a result, it's the human who have left to compromise for analytical and integration deficiencies of these different tools and technologies. And many organizations use SIM in order to manage and maintain some of these capabilities. And SIM don't work for many organizations. And there is a big reason why. Most SIMs were born at a time when big data is measured in tens or maybe hundreds of GBs today. But today, many large organizations are challenged by hundreds of terabytes of data a day of just log ingestion, which can translate into tens of petabytes data for historical analysis, for compliance reasons, or for incident investigations and response. And this data comes from all sorts of sources, whether it's endpoint threat detection and response, network sensors, or from cloud sources like AWS VPC flow logs or CloudTrail logs. So security teams really need a better way to manage and work with this data. Let me share a couple of use cases, but I want you to imagine these use cases in your environment and see how will your teams do. Because of these examples are from what many of our customers have shared with us. Imagine a situation where some SOC manager goes up to analysts and say, here are hundreds of indicators of compromises, hundreds of IOCs. Have we seen this before? Now, in many of large organizations who use STEM or large log aggregation tool, if data volume is large, this kind of search may take hours or even days to reach of search time. Because of these IOCs may include IP addresses, may include domain names, and these may take very, very large time window to search. Another example is let's say you have a threat hunting team, and your threat hunting team wants to detect particular threat actor in an environment and see if the threat actor was persistent or presented in your environment for the last 18 months. In order to do this, your threat hunting team wants endpoint threat detection logs, may need proxy logs, perhaps firewall data, DNS logs, authentication data, and go back about 18 months. For all of these data sources, most organizations can't afford to keep that much data later on to be able to operate on it. And as a result, threat hunting teams are often challenged to may have to operate on a subset of this data to come to a total conclusion. Another task, running an anomaly detection with both rules and machine learning, but not just singular rule, but chain of rules. So you can almost apply a tag framework to a given threat and be able to apply that within your analytics platform or your SIM through streaming and batch analytics. Doing stream analytics on most SIMs is very difficult, and it is very challenging on Splunk. And so organizations just give up on it, and they resort to doing basically saved search and report to understand threats. They would be understanding in a streaming fashion, and all of these three use cases can get even more complicated when you try to detect threat in multi-cloud environments. Many organizations that we speak with say this SIM's deployment in one cloud, and if you are using SIM deployment, your Splunk is either on-prem or on AWS. So if you are an Office 365 customer, for example, and you want to analyze those Office 365 logs or investigate a threat or an incident, you will have to move these logs to AWS, and then you will have to pay for egress cost, which makes it constraining to use these SIMs because they are not multi-cloud and therefore can't have consistent posture across your environments. And of course, if your team is really advanced and you want to be behind and you want to go behind just analyze logs, you want to analyze packet captures or PCAPs, or you want to understand the analysis binaries. You can't do this with SIMs or log aggregation tools today. You have to use specialized siloed tools in order to do that work, and it is really disconnected from all over your security operations. So hopefully This gives you a sense, and those examples resonate with you. These challenges are real in lots of organizations, and these challenges are real for your environment with Splunk. In the next few slides, I'm going to show you examples of how customers are using Lakehouse to reduce their cost, to reduce their complexity, and achieve multi-cloud security posture by integrating Databricks with Splunk. So, how does this relate to Splunk? When we talk to customers about Databricks for cybersecurity, many of them said our analysts love Splunk, but Splunk is very costly. And even though it's costly, managers are stuck because they don't want to forklift their security operations and start from scratch. But what both managers and security analysts want to be able to do advanced analytics capabilities with machine learning and AI capabilities, and the organization is really want to lower their cost, and they want to have consistent SecOps operations across cloud or even within one cloud. So this is why Databricks. We put together a Databricks add-on for Splunk. It allows you to use power of Lakehouse without having to leave your Splunk environment, but still keep your existing processes and procedures, and at the same time reduce cost and improve your security posture. The Databricks add-on for Splunk has three major capabilities. It is certified add-on, and it allows you to execute queries, jobs, and notebooks from Splunk UI, or from Splunk saved search, or Splunk custom commands against Databricks. And you can see the results back at Splunk UI or Splunk indexes. It creates a bidirectional capabilities to pass results or messages or events back and forth between Databricks and Splunk. And so much so, even if you have views and dashboards within Splunk that are driven by data that resides in Splunk, these views and dashboards can be driven from data that resides in Databricks, or combination of mixed dashboards of data resides in Splunk and data in Databricks. So it really makes it easy for your teams to take advantage of Databricks while they stay comfortable using Splunk. There is another example where you're familiar with Splunk. This accessing data from Splunk is just through another command, just like any other commands. And these results in this example, as you can see, are the search results coming from Databricks. And search in the search bar is actually a query in the data in Databricks, and the results are coming back from Splunk UI. So what are the deployment patterns our customer are actually deploying this and using this as sort of technical implementation level? The pattern, what we see, most customer is sending their high volume data to Databricks instead of sending this data to Splunk. The other advantage of that is Databricks is highly performant. It helps our customer to accelerate their security operations and reduce their cost simultaneously. The customer sending high volume of data to Databricks and low volume of data to Splunk and do alerts and dashboards. The second pattern we see, they send same copies of data to both Splunk and Databricks. And the reason why the customer are doing this is because they have smaller retention window for Splunk, let's say last 90 days of data into Splunk, but they want longer time historical window. And so they send copy of the data so it can be analyzed by Databricks. So if they need to go back in time, they go to Databricks to understand their historical analysis. Or if they want to run more complex machine learning and AI models against these datasets, they run these patterns inside of Databricks. And here is the real customer example. I've talked about performance. I've talked about cost saving. How does this integration reduce cost or improve your cost efficiency? Here is an example from a global media and telecommunication industry who was before they start using Databricks, they were also Splunk customer. And before they started using Databricks, their current state was ingesting 10 terabytes of log data per day. And they were able to retain these logs for 90 days. And you may know it took average about 250 days to detect a breach. So if someone collecting only 90 days of data, they are running pretty blind and missing a lot of threats and perhaps even significant breach that happens in their environment. And this customer wanted to expand this data ingestion and their retention period as well. So first option is to stay with Splunk, but the thing was that they had very limited amount of budget and they had $1.8 million to enhance their security operations. So their first option is to stay with Splunk and to spend this 1.8 millions with Splunk alone. They would be able to increase their data volume, the data ingestion to 12 terabytes of data per day, and improve their retention period to 180 days. Definitely an improvement from 90 days, but not as much as they really want to get a good posture. So what they chose to do was to augment the deployment of Splunk with Databricks within the same amount of 1.8 millions. And they were able to expand their total collection of volume of data to 35 terabytes per day and expand the retention period to 365 days. This really enabled the team to collect very large volume of data into Databricks from sources they were not able to see at all, and also allow them to look back for longer period of time for their threat hunting team and also their compliance reasons. So with the same $1.8 million really helped them improve significantly. So let me show you a demo on how the Splunk and Databricks would work together. So this is a Splunk UI, as you are all familiar with. And within Splunk applications, we've got Databricks add-on for Splunk. And once you install the application, you configure it through a JDBC connector, JDBC driver. So this can handle the communication between Splunk and Databricks. And you create with Databricks access token. You can also create your Azure AD token just to secure communication between Splunk and Databricks. And then once you do this, you can easily, now you can have Splunk and Databricks can talk to each other seamlessly. And as you can see here from the Splunk UI, these are like a saved query search. So for example, let's pick up this one and let's get all the time of historical data here from Blue dataset. And here we are just configuring connection. This is literally just like as a reference to a connection string you've already created to allow this communication and integration between Splunk and Databricks. And DBX query is basically a custom command that allows you to invoke and execute Splunk queries and query the data actually from Databricks, not from Splunk index. So in here, we're just selecting a few fields, doing some aggregations from local table, we group by and order by, and then once we run it, it will bring back the results. And this is actually without having to touch Splunk indexing. So you are reducing your costs significantly. And at the same time, you are able to achieve what you'd like to do. So this is from Splunk UI. I'm not sure how many people is familiar with Databricks in general. Is anyone in this call is familiar with Databricks, or have you heard about Databricks before? You can just raise up your hand or come off mute. Yeah, cool. So I've got few people are familiar with this. For those who are not familiar with Databricks is basically a PaaS service that's built on cloud to run for cloud, right? And as we said, because we are supporting multi-cloud, you can run on Azure, on AWS, or on GCP, and it will be the same end user experience. And it's all web-based, so you don't have to install any software or any libraries. It is basically what we do is we bring compute, we leverage the massive parallel power processing or MPP architecture to be able to query massive amounts of data, could be up to petabytes of data, and then aggregate this data and present the results back to the customers. So for those who haven't seen Databricks before, this is the UI, or we call it Databricks Workspace. This is the landing page for all the data personas to log in and connect and start leveraging the data. So whether you are security analyst, data analyst, engineer, or data scientist, you are using same UI, same tool to be able uh, to query your data, to ingest your data, to analyze your data, create some reporting and dashboarding, and also create your machine learning models as well. So first and foremost, you need like a tool or an IDE to be able to write your code. And within Databricks, we support almost so many languages. So we support Python, we support SQL, we support Scala, we support R. So whatever programming language you are comfortable with, you can just literally write them on Databricks, and it will able to run your code seamlessly. The other advantage is Databricks come already pre-installed with all the software that's required to do your job. So you are no longer have to worry about dependencies between different software versions, or upgrading your software versions, or if I upgrade this package, do I need to upgrade the other package or not? And all of these version conflicts and stuff like that. So Databricks make it easy for you to not to worry about managing all these dependencies or installing software or managing version conflicts. You can literally start immediately and start creating some work and start providing value to the business as well. So Databricks Workspace, where you have all the notebooks. And if you are familiar with Jupyter Notebooks, for example, it works exactly same way. And as you can see here, you have all users who have access to the notebooks. And then you also have everything that you need to be able to write your query. So for example, this one notebook, it is basically you can run SQL queries, as you can see here. And in the same notebook, you can also write some Python as well. When we scroll down, you will see like some Python code here. If some people, anyone in this call has got some hands-on Spark, or familiar with Spark or ANSI SQL, or writing Scala code, or any programming. Okay. So basically, what you can do to be able to curate your data and manage your data and start doing some data analysis for, as we said, like for threat hunting or for threat detection or any of these use cases, you can easily query this data from Databricks notebooks, and it requires compute. So you write your code in here. So this notebook is considered as your IDE or your development. And this compute here, it is basically a compute power to be able to run and execute your code against your datasets. So when you have Databricks integrated with Splunk, you will get best of both worlds. So you will have a Splunk UI which you are comfortable with and you are familiar with. You can run your Splunk queries and get the data from your lakehouse using Databricks without actually having to hit the index server. So you decrease the load on your index server, and at the same time, you will be able to query enormous amount of data, especially when we talk about like doing joins and aggregations and some of these complex queries. You will also be able to create machine learning and AI experimentations and models and make use of them for things like DNS analytics, for example, or IOCs, or any of these machine learning use cases that you may not have been able to do before due to some of the constraints that we spoke about before. So basically, this is the UI of Databricks, where you can write your code, the language that you are comfortable with, whether it's an SQL or whether it's Python or whether it's Scala or R. You can ingest your data, you can curate your data, you can create your reports and dashboards, you can create machine learning models. And at the same time, it will give you the ability, as you can see here, you still can see my screen, right? Can you see the Splunk UI? Anyone can just tell me in the call if they still can see my screen and they can see. Yeah, perfect, thanks. So from the Splunk UI, you can run your commands like your Splunk commands that you are familiar with. And as we said, you can hit Databricks and query the data and return the results back without actually having to create too much load on index servers. So using the two deployment patterns that we spoke about, whether you'd like to ingest a smaller amount of data to Splunk to use it for alerting and dashboarding, but you'd like to keep a huge amount or ingest a huge amount of data into Databricks. So you try to reduce your cost at the same time, be able to achieve the same things and even more. Or you can ingest data or replicate the data into the two systems, one for Splunk and one for Databricks. But at the same time, for retention, you'd like to retain this data into Splunk, as we said, for example, like for 90 days or something. But for your governance and compliance requirements, you would like to return this data for even longer period. Could be like 1 year, 2 years, 10 years, whatever. And at the same time, try to control the cost and bring it down as much as you can. So using these two deployment patterns, you will be able to achieve this goal and stay on the top of your security operations requirements. You will be able to respond to requests from threat hunting team or from security operations manager team. You will be able to create lots of things and unlock lots of potential without actually having to blow out your budget that you would like to do. So if you want to get started, I want to share with you a couple of proof of concept example scenarios our customers have conducted. And maybe you can think about something similar. It depends on your environment and your organization's requirements. So the first one, and it is very prevalent, many organizations, is IOC match problem, where somebody can come and say, here are hundreds of IOCs or 200 of IOCs, indicators of compromises, where domain names and IPs and maybe email addresses or user IDs, and go look for them. We did this for customer before. They were concerned about Sunburst backdoor, and they wanted to see if they have been impacted. And they want to do this over 1 year period of time. So they moved the data into Databricks and wanted to see if they can analyze this information and detect these IOCs within their datasets. The second use case is an integration with your data lake itself, which may be your primary use case, which you already have Splunk and you want to collect some amount of data. For this particular customer, they were collecting more than 10 terabytes per day, and they wanted to see how quickly they can query the data from Splunk into Databricks and how quickly they can empower different personas into their environment and reduce cost and accelerate time to response. The third scenario is from a customer who wanted to make significant leap in their capability by using Databricks. And they wanted to do is they want to combine endpoint threat detection and response, EDRs, and the network data and do multi-stage analysis and enrichment automatically. And they wanted to do this is to analyze every single PowerShell execution that would come to their environment and run it through a series of analytics for enrichment, for machine learning, for rules-driven analytics, and send that alert that came as a result of this analysis to SIM. So from analyst side, they shouldn't just say there is a potential PowerShell malware in their environment. They would say you have a ransomware in your environment, and here are the reasons. The analytics are saying there is indeed ransomware in the environment. So how would you get started? If you'd like to get your hands dirty and you'd like to get up to speed, I would encourage you to sign up for Databricks free trial license. Go to databricks.com/try Databricks. Go and install Databricks add-on from Splunk App Store. You can also schedule a use case design workshop, and we are working with Skillfield, one of our partners here in Australia. If you'd like to arrange a use case or a POC or a design workshop, feel free to reach out to our friends in Skillfield. The email address in the screen, info@skillfield.com.au, or feel free to hit me up anytime on LinkedIn. My name is Osama Mansour on LinkedIn. And we will be more than happy to work with you collaboratively and help you achieve your goals and help you explore more potential of your data that you were not able to or you haven't thought about. I can get more value of this data before. So that comes into the end of our presentations. Thanks for your time. This is time for a Q&A now. If anyone has got any questions, feel free to ask.